Hello and welcome to Functional Skills Maths. Today we're going to be looking at the topic of gradient. I'm just going to share my screen with you. It is a level 2 topic that we're looking at, and it shares the same criteria point as coordinates, really, which is point 22. Now, what is gradient? You might be asking. Well, the gradient is all to do with how steep a line is. So we can think of some nice small gradients, for instance, which are great when you're cycling. Just a nice cycle along a flat stretch of country lane or cycle path. Or we can think about some big gradients, like what would be quite useful if you're going out with a pair of skis on the Swiss Alps. You've got a nice mountain to come down a nice steep slope. So gradient is all to do with how steep a hill is, really. Now, if we apply that to graphs and try and draw these gradients on graphs, we can end up with different steepnesses of lines. So let's have a quick look. Which do you think is the big gradient? That's right, it's the red one. So a big gradient gives a nice steep line, and the blue line there is a small gradient. It's giving a much shallower line. Gradients can also be thought about in terms of a positive and a negative gradient. Now, a positive gradient is when the numbers are positive, and this is when you're going up a hill. So if we have a look at the picture here, we see the cyclist on the right-hand side cycling up this hill, struggling away, putting in some legwork. He's going up. And conversely, we can think of a negative gradient, which is when we're going down a hill, which is actually often a lot more fun. But hey, a negative gradient is when we're going down, and so we end up with a negative number. And again, we can look at these on graphs and plot them. We've got a 4-quadrant graph here. Now, out of these two, which would you say is the positive gradient? If you said the red line, then you'd be right. Well done. The red line is the one where you're going up a hill, because you start here on the left, and you go upwards up the mountain. And the blue one is where you start over here on the left, and you go down the hill, like you're skiing or cycling downhill. And so that's the negative gradient, when you finish lower than what you started. Okay, we've got 4 images here on screen, A, B, C, and D. The question is, which of these has the smallest negative gradient? I'll give you a few seconds just to process these and settle on your answer. Okay, have you got an answer yet? Well, if you said B, then you'd be right. A and D are both positive gradients, so we can discount those straight away. You're going up a hill. Imagine starting on the left-hand side, you're cycling up. So we can discount those. And then it's out of B and C. Now, C is quite steep, whereas B takes a long time to drop just a little bit in height. So B is the smallest negative gradient. Now, how we find the gradient is what we're going to look at next. And we use this formula: change in height divided by the change in distance. So write this down somewhere, highlight it. On the first page of your notes about gradient, it'd be a great place to put this little formula. Gradient equals the change in height divided by the change in distance. And this is true whether it's a positive or a negative gradient. The only thing with the negative gradient is that if we know we're going downhill, we'd put a minus sign in front of the number, but it's worked out exactly the same. Now let's have a look at a graph here. Let's bring the formula up. There's change in height divided by the change in distance. And looking at the graph, it tells us on the left, on the vertical axis, that these numbers represent the height in meters. And it tells us on the bottom, on the horizontal axis, that this is the horizontal distance in meters. So first of all, we need to work out what the change in height is. So if this represents the height, we've started at 2 meters high, and we're finishing at 9 meters high. So in all, we've gone upwards 7 meters. 9 take away 2 is 7. And then if we're looking at the horizontal distance, we're looking at the distance between 1 and 8 meters, which again is a distance of 7 meters. So this one actually turns out to be quite straightforward. Is that 7 is the height, that's the change in height, divided by the change in distance, which is also 7, and that equals 1. So we can say that the gradient is 1, or if we want to put it as a percentage, we can just times that by 100 and say the gradient is 100%. Okay, so look at another example. Here we have the gradient again, represented by this line across the page, a lot shallower this time. I'll tell you what, have a think about this. Press pause if you like. I'm going to stop for 10 seconds. See if we can work out what the gradient is, and then we'll run through it. Okay, well, how did you get on? If we bring the formula up once again, change in height divided by the change in distance. So what is the change in height here? Well, we start off at 4 meters high, and we finish up at 5 meters high. So not much change at all, just 1 meter, in fact, is the change in height. And the change in distance is the distance between 1 and 6. So 6 minus 1 is 5, so it's a distance of 5 meters. So our sum is this, 1 divided by 5. 1 meter change in height divided by 5 meters change in distance equals 0.2. Now that's the decimal. Now again, if we times that by 100, we'll find that our gradient is 20%. And that's often how gradients are measured. And that's not an uncommon one to see, actually, out and about on the roads. When you're driving along or when you're cycling along, you come to a steep hill, and they'll sometimes have that gradient written up for you on a sign, just to give you a warning that you're about to either go up or down a fairly steep hill. And 20% is actually quite a common one that they put a sign up for. Yeah, cycling up 1 or 2 of those is quite hard work, but coming down the other side is great. Anyway, let's have a look at the third one. So again, I'll just give you a few seconds to think about that. Press pause if you like. Try and work it out. And we'll run through shortly. Okay, so what's the change in height then? Well, it's 3. It's only 3. 1, we start off at, big part, it's 4. We start off at 0 meters high, and we go up to 4. So we've got a height of 4 meters divided by a change in distance of, well, the gap between 1 to 7, which is 6. So 4 divided by 6. If you've done your fractions work, you'll know that you can simplify that actually to 2 divided by 3. And then if you've done your fractions equivalences work, you will know that as a percentage that's 0.66666, sorry, it's a decimal. So we can round that then to 0.67. But when we times that by 100, we end up with 67%. Some of you fraction whizzes out there might be saying to me, Tim, that's a fraction, surely that's, sorry, as a percentage, surely that's 66.67%. And you would be right. So you could give that as your answer if you wished. But if we just round this up, just use a little bit of rounding here to the nearest whole number, 67% is an absolutely fine answer to give for the gradient here. So very good. Very good. Let's have a look at another example. Number 4. So again, I'll put the formula there. I'll give you a few seconds and then we'll run through this shortly. Okay, so what is the change in height? Well, this time we've got a different scale. The change in height is from 25 down to 10 meters high. So 25 take 10 is 15 meters is the change in height. 15 meters divided by the difference between 5 to 35, so that's 30. So 15 divided by 30, which is 0.5. And then times by 100 is 50%. So there's a gradient of 50%. And because it's going downhill, it's a negative gradient. So therefore, you can actually say it's minus 50%. Okay, example number 5. Same again. There's the formula. I'll give you a few seconds and we'll run through shortly. Okay, so the change in height this time is 20. The change in distance is 6. Beg your pardon, is 5. That's right, because it's from 2 up until 7. So 7 take away 2 is 5. So 20 divided by 5 is 4. And 4 times 100 is 400%. So the gradient here is minus 400% because we're going downhill. Now, that seems huge, and it is huge. It doesn't look that huge, particularly on the graph here, because the scaling is changed quite a bit. So we're going up in blocks of 5, whereas we're going across individually in sort of single unit blocks. So you might expect to see as a minus 400% gradient, you might expect to see a line that's a bit steeper, a bit more like that, for instance. But just because of the way that the graph is scaled, then that's why it's a kind of shallower line. It looks a bit more ordinary, I suppose. Okay, so look at the next example. So formula once more. See if we can calculate this. I will run through shortly. Okay, so the change in height this time is, well, we start off at 5 meters high and we finish at 2 meters high, so that's 3. And then the horizontal distance is between 1 to 7, which is 6. So 3 divided by 6, which is 0.5. And 0.5 times 100, as we saw earlier, is 50%. We're going down, so it's a minus 50% gradient, or a negative gradient of 50%. Okay, last example then. I'll give you a few seconds again and we'll run through shortly. Okay, so the change in height is from 40 down to 10. So that's a change in height of 30 meters. And the distance that we've changed is, well, we start off at 0 meters. So we've traveled 50 meters along in a straight direction. So we've got 30 divided by 50. And some of you fraction whizzes again will know that you can simplify that fraction to 3 divided by 5. And 3 divided by 5 is 3/5. 3/5, 0.6. 0.6 times 100 will get you to 60%. And so the gradient is over minus 60%. Now, these questions might come up on the non-calculator paper. And if they do, be assured that they will only deal with fractions, percentages, calculations that you can work out in your head or on paper. They'll be based around some of those common fraction families. So let's have a look at a mock exam question, for example, to show how that might play out. And here it is. So the question is, which one of the following slopes has a gradient of 30%? So you've got 4 little images there, and the measurements written appropriately by them. So you're not allowed to calculate. What you'll need to do is put that into a fraction format first of all. That's what I do, like what we've been doing. Change in height divided by change in distance. And then see if you can simplify that fraction and then convert it to a decimal and then finally to a percentage. Okay, I'll give you 10 seconds, but please do feel free to pause. This is worth 1 mark, so in an exam you'd have about 90 seconds or so to actually get your heads around this and do all the work in zone. But I'll give you 10. You take as long as you like. Okay, right then. So how did you get on? Hopefully you managed to work these out. So let's take the first one. 2 divided by 6. Change in height is 2. Distance is 6. So 2 divided by 6, we can simplify to 1 out of 3. So 1 divided by 3. And from your equivalences work, you'll know that that's 0.33. 1/3 is 0.33 or 33%. But it's not that one. Have a look at the next one. We've got 3 out of 10, or 3 divided by 10. And that 3 divided by 10 is 0.3. Aha. Times that by 100, and we've got 30%. So B is actually the correct answer here. But we'll move on and we'll just double check the others just to be sure. So looking at C, we've got 10 out of 30. So 10 divided by 30, let's simplify that again. Take the notes off. 1 divided by 3. Oh, that's going to be the same answer as the first one, actually. 1 divided by 3, 1/3 is 0.33. Times by 100 is 33%. So, yep, it's not that one. And the final one, 2 divided by 15. We can't really simplify that anymore. We could try 1 divided by 7.5, but it doesn't work. It's a decimal. Who knows really what 2 divided by 15 is? That's the sort of red herring there, in a way, in this question. You wouldn't be expected to know that, actually. But if you did want to try and get an approximation, I suppose what you could do is 2 divided by 16, which is 1 out of 8, or 1/8, which is going to be, as a percentage wise, that's going to be, or as a decimal, it's going to be half of whatever a quarter is. So if 1 out of 4 is 25, or 25%, then 1/8 is going to be 12.5%, or 0.125 as a decimal. So we know it's not that one. But as I say, if it's a tricky one to work out, then you can be pretty sure that's not going to be what they expect you to be able to do in your head. I've just rounded it up there to 0.13. So yeah, just revisiting these again. 33%, 30%, 33%, and 13%. So B is our answer. Okay, so hopefully that method is okay with you. Hopefully you're fairly confident with that. If you want to look back over any of this video, then please do. If you want any further help, please have a look at the worksheet, talk to your tutor. Today we have covered how to calculate the steepness of a line, or to calculate the steepness of a gradient, both positive and negative. So thank you for joining me, and I wish you all the best with the rest of your functional skills course. Take care for now.